Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over the ideal gas law. And the ideal gas law is a really useful law in solving for gas problems, especially when there's no change involved. So if you have a gas problem where they give you a set of conditions and they don't say anything about what the final and initial conditions are, or that the pressure was changed or temperature was changed or anything like that, they just give you a set of conditions and they're asking you for the missing condition or the missing property of the gas, then you know you have an ideal gas law problem and you're going to have to use the ideal gas law. Now, what is the ideal gas law? Well, that's I have to go back to the combined gas law to show you. So if you remember, um, we had volume is proportional to or inversely proportional to pressure. We have volume is directly proportional to temperature, and volume is also directly proportional to the moles of the gas. And the combined gas law, we just combine those together, right? So we had volume is proportional, excuse the squeaking, is proportional to temperature times the amount of gas over pressure, right? And then what we did is, like the other gas laws, since these are proportional, then there must be a proportionality constant that makes it equal, right? And so we've been calling that K. So volume is equal to temperature times the amount of gas in moles divided by the pressure, and that's going to be multiplied by some value K, some constant. And then we solved for the constant. So we got V times P over T over N, and then that was equal to some proportionality constant K. Well, in this case, K is actually known. So K has a special name and a special letter that goes with it. And we call this, the letter that we give this is R, capital R. And this is called the ideal gas law constant. So this is the ideal gas law constant R, and R has a special number. It's a calculation. So the number is 0.08206, and there are particular units that go with this R value. Let me erase this so I have more space. Let's go ahead and write this equation, the ideal gas law, in its normal way in which we write it. So the way we write it is we multiply both sides by T and N and get them on this side. So if we multiply both sides by T, then the T's cancel out. We got T on this side. We multiply both sides by N. We get rid of N. We put N over here. And so the ideal gas law is written as PV equals nRT. So this is your ideal gas law. And R, again, R has the special constant. So R is 0.08206. And it's got units that go with that you have to remember the units. So the units are liter atmosphere over mole times Kelvin. So liters times atmospheres, moles over Kelvin. So you'll notice that the R value is equal to this. And notice before I solved this equation, I had PV over T and N. Volume, liters, pressure, atmospheres, temperature, Kelvin, number of moles, or amount of gas, moles. So the R equals these units, because that's what R equals. R equals P over T and N. So if these are the units, then when you're using the ideal gas law, you have to make sure that your pressure and your volume and your number of your amount of gas and your temperature are in these units. Otherwise, you're not going to cancel out the units here, and you're going to get the wrong answer. Okay, so be aware of that. So this is the ideal gas law. This is the ideal gas law constant. Now, this number, it only goes with these units. Now, if you change the units, then the number is going to change as well. So sometimes you might run into the ideal gas law and it's a different number, like maybe, I think, 8.143 or something like that. And the reason for that is because your atmospheres is changed into kilopascals, right? So because you change the unit, the value is going to change. But the R value is, I should say the number, not the value. The number is going to change. The value of the R constant is the same. The R constant, the ideal gas law constant is doesn't change as far as the magnitude, but the value here, the number here, will change depending on what units you're using. So I hope that is helpful. Again, this is the law that you would use in problems where there's no change from initial conditions to final conditions. Here's where in this problem, they're going to give you like a set of conditions. So maybe they give you a certain amount of pressure, they give you a certain amount of volume, and they give you a temperature, and then they ask, okay, what are the moles of this gas? Well, you know R, they gave you T, V, and P, so the moles of gas is what you solve for. So you solve this equation for the moles of gas. So you're not changing from one amount of gas to another amount of gas, or you're not changing from one pressure to another pressure. You could actually do that with the ideal gas law, but you would have to solve the ideal gas law twice. So you plug the initial conditions into your ideal gas law, solve for the missing part, and then you could then find the missing part and then plug it in and use the ideal gas law in the new set of conditions. So that you could do it that way, but then you'd be using it twice, which is fine if as long as it gets you the right answer. But usually the ideal gas law is used in situations where there is no change in the gas conditions. They're just giving you one set of conditions and they ask, what's the missing part? So you would then solve this equation for the missing part. I hope this was helpful. If you like the video, share the video, make a comment in the comment section, subscribe to the channel, and hit the notification bell so you can be notified for any future videos I put out. Thanks for joining me, and I'll see you next time.